Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about how to set up a simple model of a StableMoor buoy on an oceanographic mooring. What is a StableMoor buoy? It's this streamlined float that's developed by DeepWater Buoyancy. By using a streamlined float, it's able to take advantage of a lot of inertia and a relatively low frontal area to keep the float nice and stable in potentially very high flows. They can hold a number of things like ADCPs, come in lots of different shapes and sizes and lengths. They do have to be carefully trimmed in order to make sure that they're level when they're fully deployed, which is something that's operational in terms of the deployment of the mooring. But it's not really a sphere, and it's not exactly a cylinder shape like you'd want to put in ProteusDS Oceanographic, so we're going to take a look at how to set this up. And to use it as an example, we're going to work around this Osnap mooring developed by Woods Hole Oceanographic Institution. So this Osnap mooring is in about 2,000 meters of water depth, subsurface mooring with a nice stable moor near the top, providing sort of primary flotation and ADCP current measurements near the surface. All right, so let's take a look at how we've set things up. Now, what I've done is, as part of a project parts library file, I've made a single part in here, a subsurface buoy part, and set up the StableMoor buoy here. And what I've done is use the spherical geometry type. And I've got parameters for the wet weight of the float as well as the air weight, and that we can use those directly as the mass and the net uplift. The inside length is going to be the contribution it adds to the mooring, so just kind of rough representation there. The nominal diameter here is we set roughly to equal the frontal area of the whole thing. That's kind of optional. It's going to scale up the drag, and it won't affect any of the buoyancy calculations, the flotation levels, because that's what's governed by the net uplift here. So the reason we use spherical is because we're basically saying let's say it's always going to be trim in the flow. These have to be trimmed ahead of time to make sure they're nice and stable. So it'll always be presenting that sort of frontal circular area. It's a really quick way to get a StableMoor set up in a mooring using ProteusDS Oceanographic. So I've got my project parts library file, and I've already added it to the mooring setup here, so you can see I've got my StableMoor assembly here, and I've already added the subsurface buoy, and we'll type in StableMoor. There, it's showing up from the project parts library that I added to this. And of course, in other tutorials, we've seen how to set a current profile and create a static profile of the mooring, and I've already got some results to show. It being a full open ocean current, there's not a tremendous amount of mooring deflection given the size of this system. Let's go to engineering view, east. There's the almost 2,000 meter mooring, and then this deflection is not a huge amount. But still good to see it there, and of course you can play around with some of the parameters to see how the deflection changes. Anyway, all I wanted to show was a simplified way to get a StableMoor buoy set up in a mooring simulation, and thanks for watching.